Alright, welcome back everybody. This is video 2 of section 7.6 for AP Calculus, finding general solutions using separation of variables. We're going to pick up right where we left off at the end of the last video and go ahead and work through a few more examples utilizing separation of variables. Alright, so let's go ahead and move on to E. dy dx equals x times the square root of y times the cosine squared of the square root of y. And so we see that we've got, a function of y over here, and we want to go ahead and separate our variables, get our y's and our dy's over on the right-hand side, or on the left-hand side, and our x's and dx's on the right. So I'm going to go ahead and multiply both sides by dx. Which is going to give me x dx on the right-hand side. And for my left-hand side, I'm going to go ahead and divide everything by the square root of y, cosine squared of the square root of y. But then, instead of writing it as this, I'm going to go ahead and take this cosine squared and change it into a secant squared and move it up into the numerator so that my left-hand side looks like this. Okay. Now from here, it's time to integrate. Integrating the right-hand side will not be any kind of problem. The integral of that is just going to be 1/2 x squared plus a constant. In order to do the left-hand side, it would probably be helpful for me to use a substitution. So I'm going to go ahead and use u is equal to the square root of y. So du is equal to 1 over 2 root y dy. And so I'm going to replace this square root of y with a u, and then the rest of this stuff, the dy and the square root of y in the denominator, I'm going to replace with a 2 du. And so my left-hand side turns into 2 times the integral of secant squared of u du. And now I can go ahead and find the antiderivative of that. The antiderivative of secant squared is just going to be tangent. I bring my u back. And now I need to solve this equation for y and multiply both sides by 1/2. I take the arctangent of both sides to get square root of y by itself. And the entire right-hand side is inside the arctangent. And then to get y, I'm going to square both sides, and we end up with y equals the quantity arctangent of 1/4 x squared plus c, that whole quantity squared. There's our general solution for part E. Part F. Now, the problem with part F is that I've got this e to the y plus sine of x that I can't separate, but that's a problem that we can easily overcome by rewriting it using exponent rules. We can write e to the y plus sine of x as e to the y times e to the sine of x, and now I've got a function of y and a function of x that I can separate this equation into. So I'm going to divide both sides by e to the y and multiply both sides by dx. Okay, and furthermore, this dy over e to the y, I'm going to write that as e to the negative y dy. Because that's going to be a pretty easy, straightforward antiderivative when I do it that way. Much easier than leaving it in the denominator. Kind of the way we think about, dy over y squared. It's a lot easier if we think about that as the integral of y to the negative 2. All right. So now from here, I want to integrate both sides on the left-hand side, the antiderivative here is negative e to the negative y. And on the right-hand side here, I could do a substitution, u equals the sine of x, but if I do u equals the sine of x, du is exactly cosine of x dx. So this might be one of those times where, to me, I'm probably just going to do a mental substitution and do a quick check with it in the end and say, okay, I think the integral of this is e to the sine of x. Let me just quick check that in my head. The derivative of e to the sine of x is e to the sine of x times the derivative of sine of x, which is cosine of x. And so it perfectly matches. If it helps you to do the u substitution, go ahead and do the u substitution to help you do that integral accurately. All right, now from here, we're just going to go ahead and solve for y. We multiply both sides by -1. And when we multiply a constant by -1, it's still a constant. We take the natural log of both sides. The natural log of e to the negative y, since it's a single term, is just going to be the exponent of that. Over on the right-hand side, we've got two terms, though, so we need both of those to be inside the natural log. And so we're not going to be able to get rid of that e because it's just one of multiple terms inside the natural log. And then we want to multiply both sides by -1. And we get that y is equal to the opposite of the natural log of negative e to the sine of x plus c. We could also, using exponent properties, since I've got this negative sign out in front, I could use that as an exponent inside, and I could rewrite this as the natural logarithm of 1 over negative e to the sine of x plus c. That would also be acceptable here. All right. And then part G, dp dt is equal to 0.08p. Notice there's no t here, but this is still separation because the variable that's in my numerator of my differential is on the right-hand side of the equation. So I'm going to divide both sides by p and multiply both sides by 0.08. A little recommendation from experience: so much better here when we're doing separation if we just leave the constant on the right-hand side when at all possible. When we have a multiplicative constant, let's just leave it on the right-hand side. And now we've got something that we can integrate. This is going to be natural log of the absolute value of p is equal to 0.08t plus a constant. And then I'm going to raise both sides e to that power. Gives me absolute value of p equals ce to the 0.08t. You saw that in the last video, how that turns into the constant being a multiplicative constant in front. And then, of course, because of the absolute value, this is plus or minus ce to the 0.08t. Although, like I said, in most cases, I'm just going to go ahead and absorb that plus or minus into the constant of integration. So I would take either of those. All right. There's one more example problem in this lesson. And for those of you who are in AB, this is a content or a skill set that you do not have yet. You are not able to integrate this. So I'm going to do one more video with just the BC example that we have left in this lesson. All right, so I'm going to go ahead and sign off here, and we'll come back for a third video on this section. All right, have a great day, everybody, and we'll see you next time. Bye-bye.